Thank you, Michael. I'm really excited today to talk to you about Databricks SQL, the product we built to deliver high-performance analytics on the lakehouse. But before I dive into the product, I want to talk to you about why we're working on this. Since the beginning of Databricks, we always knew SQL would be important and have invested heavily in SQL. But 2 years ago, we started seeing some acceleration of SQL usage on Databricks. So we started interviewing a set of customers who are using a lot of SQL. And we're surprised that they universally told us the same story over and over again. They used to have a bifurcated architecture that stored all of their raw data in the data lakes managed by Databricks, and then ETL a subset of those business data into data warehouses. However, inevitably in some cases, some analysts would want access to the raw data, so they had to open up access via Databricks using SQL. Some were even ahead of the curve and got rid of their data warehouses altogether and rely only on Databricks for SQL. Even among the ones that kept both lakes and warehouses, they told us they did not want another data warehouse because it was too complicated to have two systems side by side. They needed to ensure data were synchronized, access control were enforced exactly the same way, and not to mention the operational complexity of having two systems side by side. So although Databricks 2 years ago worked for some early adopters to replace data warehouses, SQL really wasn't a first-class citizen yet. And in response to those requests and customers' demands, we decided to accelerate our investment to make it so, to deliver the following vision. And we coined the term lakehouse to reflect our customers' desire to combine the best of data warehouses and data lakes. The lakehouse provides one source of truth for all data to enable all workloads from BI to AI. And of course, we also want to provide the best performance at the lowest cost possible. Now that said, very few people in the industry actually believe it was possible at all. The ongoing wisdom in the industry is that we would need specialized systems for specialized use cases, especially for something that's performance sensitive. As a matter of fact, Michael Stonebraker, who's a Turing Award winner, one of the most respected pioneer in the database community, actually even wrote a paper about this based on 25 years of wisdom called One Size Fits All. Wouldn't no longer apply. It's not just Michael Stonebraker. Our customers, competitors, even partners had doubts. It just didn't seem possible to have the cake and eat it too. Some said it would take more than a decade to get to state-of-the-art performance for SQL on data lakes. Some just said it was plain impossible to get good performance out of data lakes and open formats. So in the rest of the talk, I want to explain some of the concrete challenges we faced in this journey and how we went back to the drawing board and built. This is not an architectural diagram that you need to understand, because when you work with Databricks, we present a coherent product to you that you don't need to take care of the different layers yourself. But I'm going to be diving into each one of the three major layers in the system in order to explain the challenges. The first is at the very bottom, the storage layer, and it's how we store and govern data. The compute layer is how we process queries, and the very top, the consumption layer, all the tools you use to interface with the system. These layers are not specific to lakehouse. They're actually generic to virtually any data systems. As a matter of fact, you can think of a data warehousing system this way also. So let's look at each of the layers in turns. And we'll start from the very bottom, the storage layer. Data lake storage systems are really good for its openness and flexibility. And the openness creates very little vendor lock-in, and the openness and flexibility supports all the data types, and in particular also supports schema on read. This key attribute of schema on read is very important because it allows you to dump all the data very quickly into the data lake. But this schema on read also comes at a very high cost of low data quality, because if you don't even know what you are dumping in, how can you actually understand it? Now, data warehouses are great for the opposite end of the spectrum. It is proprietary and it's very rigid. You have to think about data modeling before putting data in your data warehouses. But this rigidity, even though it sounded negative, actually leads to great data quality. Because now you can actually enforce what type of data, the schema, the constraints you put into the data warehouse. And historically, data warehouses have spent a lot of time optimizing for the performance and the governance aspect as well. So in order to bring the best of data lakes and data warehouses, we need to support the openness, the flexibility, and yet the quality and the performance and the governance. Is that even possible? How can you be flexible and rigid at the same time? The way we solve this problem is by creating two new pieces of technology, Delta Lake and Unity Catalog. Delta Lake is an open source storage format built on top of Parquet, but adds a lot of the data warehousing functionalities for storage, such as schema enforcement, asset transactions, and a lot of performance improvements. Unity Catalog adds a governance layer on top. But I haven't answered the question of how we can be flexible and rigid at the same time, and as a result having high quality. The way we do this is actually pretty simple. You can ingest raw events very easily into the Delta Lake, just like your normal data lakes. But as you refine data, you can add more and more structure to it. And we call this pattern the bronze, silver, and the gold pattern. You start it just like a raw data lake in your bronze tables, but by the time you get to the gold tables, the tables are high-value business metrics. They have all the schema enforcements and constraint applied, so you know we can trust all this data. And this way, you retain the flexibility of data lake at the bronze level and the silver level, and high-quality business data at the gold level. Now, just a few words on Unity Catalog because we already have 2 other talks that talked about it. Unity Catalog provides a unified governance catalog across all clouds. And the key here is not only does it support SQL workloads, but support all of the Spark workloads and all of the programming languages, from Python to Scala to R. So this is the storage layer. We built the new open source standard, Delta Lake, with the flexibility of data lakes and the reliability and performance of data warehouses. And then Unity Catalog to provide the fine-grained governance on top for all clouds. The next layer to look at is the compute layer, and this is how we process queries. Spark has been the de facto standard for data lake compute. It's really great for processing terabytes and petabytes of data cheaply. But historically, Spark doesn't run SQL that well, and it can be very difficult to configure. Data warehouses, on the other hand, tend to support short-running queries really well, especially have a lot of users issuing queries concurrently, just like a lot of data analysts or business analysts. It tends to be very easy to set up, but when you need to process a lot of data, either it just wouldn't work or it would become too costly. A popular belief is that large workloads and high latency, small workloads will require dramatically different systems to handle. For example, the classic trade-off in computer science is between latency and throughput. You have to sacrifice one for the other. But after spending a lot of time analyzing the systems, we found that it was possible to simultaneously improve large query performance and small query performance in terms of concurrency and latency. Although the classic trade-off definitely existed, the trade-offs are only really explicit and become trade-offs when we optimize the system to a very theoretical optimum. But it turned out vast majority of software, and this includes all data warehouse systems and Databricks, were far away from the theoretical optimum. So what we did was we went back to the drawing board and completely rebuilt what a modern-day compute engine should look like. We built a new C++ vectorized query processing engine called Photon. We built a new gateway service for automatic load balancing of queries across a set of underlying compute physical resources. And we'll automatically warm up VMs under the hood to give you the compute resources on demand in seconds. But what's best is all of this complexity, all of the names I just told you are hidden from you. You just need to click a few buttons to operate. And this not only brings the best performance, but also very much of a serverless experience. And next, I will show you 2 benchmarks showing how we perform in large query performance as well as small query performance against data warehouses. So the industry standard benchmark used by data warehouses is TPCDS. It includes about 100 queries that ranging from very simple to very sophisticated to simulate decision support workloads. And this benchmark was created by a committee formed by data warehousing vendors in the past. The first benchmark I want to show you is a 100 terabyte version of TPCDS. And the chart here is normalized based on the cost of the system, since for large workloads, ultimately the number that matters is the performance cost instead of how fast the system would run. Databricks SQL actually outperforms all cloud data warehouse we measured by up to almost an order of magnitude. To be able to beat data warehouse in their own game is actually a huge accomplishment. The second benchmark I want to show, again, is TPCDS, but this time running at 10 gigabyte scale factor. So 10 gigabyte is a much smaller version than 100 terabyte and simulates really well a lot of the business data that's been aggregated. But instead of running the queries one by one, we're doing a concurrency test of 32 concurrent streams. And this will actually simulate a lot of interactive queries analysts will be issuing. When we first started working on this about a year ago, the performance weren't great. We're only able to get half of a concurrency compared with the leading cloud data warehouse. But as we roll out the new system, we improve the concurrency by almost threefold. And now it's even outperforming the leading cloud data warehouse in short queries. So this is the compute layer. We rebuild the query engine from scratch to deliver the best performance, both for large and small workloads, regardless whether it's single stream or concurrent. The last part I want to talk about is the consumption layer, one that's often actually overlooked by hardcore system builders. Similar to a lot of other layers, the consumption layer will have to bridge the best of both worlds together. Data lakes were really good with its open APIs and programming languages for data science and data engineering. This includes Scala, Python, R, and also the notebook interface was really awesome for data scientists. Data warehouses, on the other hand, are really good for SQL and really good for all the tools that rely primarily on SQL, such as BI tools. In the lakehouse, we'd have to be able to work seamlessly with your tools of choice, regardless whether you're a business analyst, a data scientist, a machine learning engineer, or data engineer. We need to treat Python, Scala, R, SQL, programming languages all as first-class citizens to truly unify data engineering, machine learning, and BI workloads in one place. We're really committed to providing a first-class SQL development experience on the lakehouse. So in the past couple of years, we'll work very closely with a large number of software vendors to make sure you can easily use your tools of choice on Databricks. So we're not in this alone. We made it very easy to connect, easier to get data in, easier to authenticate using single sign-on, and of course, with all the concurrency and performance improvement, we make sure the integration with all of the systems are great. And your favorite tools like Tableau, Power BI, DBT, Fivetran should all just work seamlessly. Now, in addition to supporting third-party partner tools, we also focus on providing a native SQL development experience within Databricks. Based on our Redash acquisition, we're now offering a parallel UI tailored to SQL in addition to our data science and machine learning UI. But we didn't stop there. We talked to hundreds of analysts after the launch that used various SQL editors like SQL Workbench every day and worked with them to provide a dream set of capabilities for SQL. In the past few months, we've added a lot of different improvements. NC SQL support, so you don't need to learn a new special SQL dialect. Query tabs, so you can work with multiple queries at once. Autosave, so you never need to worry about losing your drafts. Integrated history, so you can look very easily at what you have run in the past and retrieve the result for them. And intelligent autocomplete that understands subqueries and aliases. It's much easier to actually author SQL with this new UI. So on top of the storage layer and the compute layer, we build a new consumption layer that offers native experience for SQL and integrates seamlessly with all the popular SQL-based tools. And this is in addition to our data science workspace that's loved by data scientists. So I've talked a lot about the inner workings and the different layers, but really no better way to explain the product than a demo. For that, I would like to invite Miranda onto stage. Miranda is a product manager at Databricks, and she'll be giving you the demo.
Thank you, Reynold. So today, I'm going to show you how easy it is to get started with Databricks SQL. In Databricks SQL, you run queries using SQL endpoints that provide low latency and infinite concurrency for SQL queries. They also magically autoscale. So out of the box, we provide you with access to a SQL editor, dashboards, and alerts that are integrated right with your data. And of course, you can also connect to your favorite BI tool as well. We're open for business at Tableau, Power BI, Looker, Spotfire, and so much more. So let's get started. The first thing I always like to do is explore the data that I have available to me. So you'll notice that here in the Data Explorer, I have a point-and-click way to understand the different catalogs, databases, and tables that are part of my data lake. And here, if I want to get a quick view of the different tables, I can get an overview of the schema. I can look at a few rows of sample data. Now, of course, all this is stored in an open format. I can see details, and I can even manage permissions with the click of a button. Now, all the users and groups that you have within Databricks SQL can easily be synced from Okta, Active Directory, or a different authentication provider. What's nice is in this Data Explorer, I can also see the history of my Delta tables, so I can understand every operation that's happened. Now, today, we're going to use the sample NYC taxi data set that we provide to you out of the box. But it is also worth noting that if you wanted to set up ingest from another source, you can do that with a partner like Fivetran with just a few clicks. Well, so let's get started querying. So here, what you'll see that we have is your SQL workbench, and this is where you author and execute queries. So let's go ahead and run this sample one. Now, of course, you can have multiple SQL statements, whether those are ad hoc queries or DDLs, in each of these tabs. I'm also going to go ahead and pin this table since we're going to use it throughout, while I can kind of go ahead through the schema browser and take a look at some of the other data that I have available to me. Now, one thing to note is you can see here that I'm using the default SQL endpoint that comes out of the box with every workspace. But what's great about these endpoints is that they eliminate the complexity of clusters. You don't have to think about versions. You don't have to think about Spark configuration. You just pick a t-shirt size, small, medium, large, and you can assign them to specific teams or departments so you can streamline governance and chargeback. And soon, with new serverless endpoints, you won't need to think about startup time either. Ready for prime time in just a few seconds. So now that we've got our results, why don't we take a look at some of the execution details? You see here that we get a nice view of what actually happened. We can also understand some of the previous executions that we've run and go back to a previous version if we'd like to. If we're really firing on all cylinders, we can also go ahead and leverage any of these keyboard shortcuts for things like opening and closing new tabs, or even executing our queries, highlighting certain portions, everything designed to make your analysis as quick and easy as possible. Now, of course, sometimes you don't just want to generate results. You also want to visualize them and share them with other individuals and teams in the organization. So why don't we go ahead and add a visualization? And you'll see that's right side by side with my results. Let's just do a quick scatter plot of the average fare by route. See if we can figure out which routes we probably want to avoid because they're a little pricey. So you can see here, I was able to quickly just add that visualization, and I can quickly spot any of these outliers that I might want to avoid when I'm planning my trips. Probably better to take the subway. So now this is great. I'm starting to generate some insights already. But what if I wanted to organize these insights, persist them, and kind of come back to them time and time again with my team? Dashboards are a great way to do this. And of course, I'm sure you've guessed by now, we provide a number of sample dashboards out of the box. So let's go ahead and pick our NYC taxi one. Now you'll see that this dashboard provides a great example of a number of capabilities you might want to take advantage of, whether that's conditionally coloring certain values in a table, or that's adding interactivity via parameters and allowing the consumers of these dashboards to set different date ranges. And what's great is if there's a key metric I'm tracking, like total trips, I can also, right within Databricks SQL, set up an alert so I know when certain thresholds are met. So here, you notice that I've selected my query total trips. I've decided I want to know as soon as we cross that magical 300 mark for that time range. And I just want to get notified once when it happens. So I'm going to go ahead and create the alert. I'm going to tell it to send to myself. And I'm also going to go ahead and decide to make sure the entire team knows too, and make sure that message goes to Slack as well. All right, so with that, why don't we jump over to Tableau, where I've already configured it to query directly from Databricks SQL and to hit those SQL endpoints. You can see here that I was able to develop that same view of my data in a Tableau dashboard. And if I want to open anything up and do some additional analysis, like let's say I want to understand kind of the difference in route fare by drop-off zip code, you can see here that very quickly I can see which zip codes are very close to each other. You can see within there, very, very short trips, very cheap trips. But if I go a little further, I can also start to get some more insights and understand where the distance is actually a little longer. And this is all generating live queries against my Databricks SQL data with the click of a button. So hopefully this gave you an idea of what's possible with analytics on the data lake, whether you want to use our built-in capabilities or your favorite BI tool. Back to you, Reynold.
Thank you, Miranda. So this is how we achieve this and manage to bring the best of both worlds together, data lakes and data warehouses, onto the lakehouse. But don't just take our words for it. Here are some examples of how customers have benefited from Databricks SQL implementing lakehouse architectures. Many have enabled business analysts to directly query data lake data using their favorite BI tools. So now everybody is looking at one source of truth of data and analyzing the latest and the fresh data without having to wait for it to be prepared and loaded into a data warehouse. And this really allows the business to respond much faster to ever-changing needs and trends. Others are simply empowering everyone in their organization to create data at no additional licensing costs. And we hear it from customers every day. Databricks SQL enables a new population within their organizations to find new insights without the need to wait for the downstream team. And finally, some are building rich and custom data-enhanced applications, either for internal organizations or to better serve their customers. The ease of connectivity, management, better price performance of Databricks SQL really greatly simplify the development of these applications at scale, and all served from the data lake. Just visit our product page to learn more about the stories. As shown in our benchmarks, we have achieved world-class performance at data lake economics. But the Databricks Lakehouse platform isn't just another data warehouse. It's about enabling the foundation for all of your workloads on all of your data. It's about enabling one source of truth for all of your data without the vendor lock-in as asked by our customers. So we have talked about how data engineering analytics workloads are supported. In the next talk, you'll learn from Clement how Databricks Lakehouse platform allows you to actually apply and store machine learning models, features, and serve predictive models and applications. Thank you.